much for speaking with us today, Mr. Overstreet.
Yeah, no problem. You can call me Mike. So I'm like right now, like a lot of people, kind of part-time contract worker, but I do computer programming and robotics. This is one of the robots behind me that I'm doing some development on. Snow, it's a large social service robot. But
Did it just blink?
yes.
That is so cool.
Yeah, it's give it a little bit kind of a human face, human interactions. It's just a like a little video being displayed on the screen. It doesn't really do react to you or anything, but yeah, I'll kind of put her on standby there. So, oh yeah, here's my brush robot, bristle robot. I just actually got this in the mail yesterday. Whoa, all right, and so kind of give you some background for me. My robotics background goes back a long way. I started out in doing Legos, Lego Challenge, the Lego competitions in school. Then I did some VEX. Then when I got to high school, I started in first. Did first competitions. Then when I got out of high school and college, I did mentored first teams. Then in 2000, I think 2005, 2006, I went to a robot competition in the Bay Area called Robo Games, and I got kind of hardcore in there. I started to get into robot kung fu, robot competitions, so on, and I've been doing it ever since. Like I said, I help other companies out with beta testing, development, software development, programming with robots. So my background in school is I actually got a bachelor's of science degree in computer programming, but there's different avenues or approaches. Like if you're in school, there's not really a bachelor's of science degree in robotics right now. Most of the people, what they do is they get an engineering degree, a programming degree, mechanical engineering, electrical engineering, programming, and then when they go for like a master's, PhD, then they specialize in robotics. But in today's world, I think as for like robots like Snow and other robots, you can start seeing more and more in the world. You're probably not going to need a master's degree, but some kind of mechanical, electrical degree, engineering degree, degree in programming would be a great start. And as robots become more and more out there, there will be more and more jobs for programming, maintenance, and help and development for the robots. But you can, if you really want to. There's no reason why you can't do a master's or a PhD. There's a lot of development and research being done right now, especially with the pandemic, COVID-19. I have a lot of friends who are spending a lot of time trying to see how they can develop robots to help with the social isolating, the six feet apart, the social distancing. Just think, I don't know if you know what telepresence robots are, but as somebody can drive the robot around over the internet, and they have video cameras and mics so they can communicate with people through the robot. So just think of if you're social isolated or because you're sick or you've got some pre-existing conditions, there's a lot of really cool things that the robots can help you do, help you socialize, help you stay in contact with people, not just through what we're doing right now, but you can actually physically move the robot around the workplace or the restaurant or your friends, your families, or maybe you want to visit your grandparents, but you can't because either you have COVID-19 or they're worried about getting COVID-19. A telepresence robot would be a great way to interact with your parents or your grandparents or somebody that you can't personally interact with them because of COVID-19. So there's lots of cool stuff going on right now in development of robots, and I think it's really cool that you guys are getting into robotics, getting into the hows and whys. Even simple robots are great, like the robots you're working on right now, because you got to start you kind of have to start thinking the robotic way, because robots right now can't mimic us or mimic, they can kind of mimic animals and creatures and so on, but they do it in their own special way, their own, by the programming or manipulating the environment around them. So just the ability to build the robots, to work on the robots, to understand how they work, how to make them better. So one of the cool things you're doing is you're taking, so this is mine, but you're taking your robot and you're trying to personalize it, make it kind of your own. You're kind of working on trying to make it better or do like little simple competitions and so on. So I think when I was looking at that PDF, you do a lot of the things I've seen people do. You had the little eyes, and the pipe cleaner to give it a little bit of color. The LEDs, I love the LEDs, but like you were saying, the LEDs can drain the battery. So one of the options you could try to do is you add a second LED just for the second battery just for the LED is an option you could do. I'm not going to recommend this, but I've seen people do this. They actually, if they have a lot of brushes, they'll actually will trim the lengths of the brushes to get it to move different directions. So I'm not saying it works really well, but I've actually seen people, so they will cut the front down a little bit, and they will actually, it sort of works, but actually make it go straighter and go faster, straightforward. So if you're like doing a race, it might help, but that's a great way to experiment. So one of the things, so I do robot development. So one of the things I do is what's called iteration. So you take a basic design, and instead of going from nothing to a finished, completed robot in one step, you take small little steps on the way to the completed robot, and that's called iteration. And to me, that's an awesome tool. I do it all the time, and another great example, I do it all the time when I do programming. So I don't go from nothing to a finished program. I start out in steps, and I break it down into small steps. Design that part, program that part, and then the key is I test it. And then once I've tested it and I know it works, then I can build on that. So the same thing with a robot. Like when you were doing the experiment with the LED, you realize that it drained the battery. So that's a good test. So you say, well, how can I extend the life of the battery? So a few options you can work on is, like I said, maybe add a second battery just for the LED. So what a lot of people have this technique where they do small little changes and updates and improvements, and then they test them. And so what they're doing is they're just testing the small little improvement they made. They're not testing everything. If you make an improvement and then test everything, they can get very time consuming. So that's why I love iteration. Small, gradual changes, test them, make sure they work. If they don't work, back them out and then restart over. Because sometimes you can make assumptions and say, oh, I know this is going to work. I just know this is going to work. But then when you try it out, you realize, it's not going to quite work as well as you thought. So even me, I do that a lot. I have these great ideas. I just like, oh, this is a great idea. I jump into it, and then I realize, oh, I thought it was going to work that way, but it doesn't quite work that way. So that's why, like I said, I love iteration. You do small, gradual little changes as you work to the completed project. And then test, always evaluate. Never assume that something's going to work just because you think it's going to work. Because there's always a chance that your idea, even if it's a great idea, there's always a chance that might not quite work the way you thought it was going to work. Or I've seen this. You come up with an idea and you start testing it, and it does something completely different than what you thought it was going to do. But actually, it's a great idea. Actually, it's an awesome result. The result is great. You just didn't realize that's the result you were going to get, and then you go, and it sends you off on another path where you can just jump in and go, oh, I didn't realize if I made this change that it would also do this too, and you realize it's doing. But the best way you realize you do an iteration. I know I keep saying iteration over and over again, but to me, iteration is an awesome tool when you're designing, developing robots from scratch. You take an idea in your brain and you make it practical. I think iteration is great. So,
I've been telling my students about first focusing on function and then on form, because if you have something that's gorgeous but it doesn't work, that's not really a robot. It's art, but it's not a robot, and we want both. So you want to start with the function and then go to the form. Is that how you approach it too, or is it with those iterations each step you do it differently?
Well, see, that's I don't want to get too involved, but the function and form and that whole concept of, do you design something for its function or do you design something for its form? It's like a humanoid robot is a great example. I don't want to get too complicated for my class or my age here, but let's say you want a robot butler and you want it to look like a human. You want it to walk on two legs. You want it to have two arms, a head and a face and everything. So you're designing towards form there because you think a humanoid form would work best as a butler, but you realize as you're doing the humanoid form, a humanoid form is really complicated. I can't stress to you how complicated. Think how long it took for you to learn how to walk. So you're a kid, you're born. It sometimes takes 4, maybe 5 years before you're really good at walking. And then it may be till you're 8, 9, 10 before you have the coordination to be really good at something. So, I mean, so a 5-year-old, a 6-year-old can maybe run around, but can they play soccer really well? It takes a lot of learning and practice. For us, it takes a lot of learning and practice. Like walking stairs, there's a lot of stuff we take for granted, because just walking is a very complicated form. So yes, you can design to form, but usually what ends up happening is that you've got to take an allowance to function. What do you want the robot to do? So there's a fine line. So a lot of people love the humanoid form and love humanoid robots, but is that very practical? Can it actually do something worthwhile that somebody else wants it? So you can design a great, cool humanoid robot that walks around and everything, but they have trouble navigating, walking upstairs, going through small doorways. Yeah, unfortunately, my house, I think my doorways are a little smaller than some houses. So it's sometimes even walking around and carrying stuff can be a chore going through a doorway, like carrying baggage and stuff in and out. So, I mean, it's a great concept. I don't want to get too complicated, but yeah, form over function is an interesting debate. And when you're in the engineering world or you're in the programming world, you're always that's an underlying issue that you're always going to have to deal with. If I design totally towards function, is the robot, see, like Snow is kind of cute. So you don't want your robot to be totally designed to function because people might not like it, you know, physically. They may not be able to connect with it. They may be a little scared of it or nervous around it because of it's the way you design totally towards function. So if you give it some kind of personality, kind of smooth the edges a little bit, make it more likable, then people might be able to associate with it. They might be able to live with it better. They might not be as nervous around it or as scared around it. But you can you can't get too close sometimes. If you make a robot that's really close to humanoid form, that also can be kind of scary too.
So it's a little freaky, huh? It scares
yeah,
people.
Yeah. So that's a great question. I love that question because you're thinking. I love the question, but it's something that we could probably spend hours on talking form over function. I mean, like with the little, like with your robots. I mean, some people like these little, little googly eyes. Other people don't. Colors, like the pipe cleaners and stuff, are a really cool idea. But like for the function thing, I've seen if you make the robot too top heavy, you put too much on top, it won't move. It will kind of move goofy on you.
Yeah. We had that problem. And when I've done this before, that's why I gave the kids all these Q-tips and pipe cleaners, because we find that there's so much energy in the 3-volt batteries. Like the little ones weren't enough to really run the motors and the LEDs, and they barely even ran the motors. But these 3-volt batteries will do a pretty good job, but they're a little bigger than the toothbrush. So the toothbrushes tip over. So they have to have something to balance it out. And we found pipe cleaners can work in different ways, and so can these. And then they can also make it move differently. So if you have so many of them, it slows it down and makes it move more straight. And if you put it in certain patterns, it'll actually make it just spin in circles. So it's like both, and you're right. In both, it's both. It's function, but it's form. It has both interacting in order. And if they had nothing, it doesn't work at all. So you got to have something.
Yeah, you gotta balance. It's always a balance. It's a great question. It's always a balance between form over function. And again, like you were saying, so where you put the pipe cleaners, use them as levers, it balances out. So if you can extend the pipe cleaner out one side or the other, it'll move a little bit differently. That's where iteration. I know I keep saying iteration, but I love iteration. And when I talk to people, I say iteration is a huge asset to you, because when you make changes, make small changes. And you may have to use lots of pipe cleaners because one length may be better than the other. So maybe you cut it long, and then you realize that's too long, and you start cutting it, making it a little shorter, and then you get the balance right, and you get the movement right, and everything works. So yeah, so form over functions is a great topic to talk about, and I love talking about iteration and how iteration is a powerful tool. In the future, this is one of my favorite tools.
Wow.
It's my 3D printer. I don't know if you've seen 3D printers yet.
We have one in our school, but I believe it's still in the packaging and it's only been used once or twice. I'd like to learn more about it. That's a really cool one.
So I love 3D printing, and one of the reasons, that's pretty heavy. Sorry. So one of the reasons why I love 3D printing is that you design a part in your favorite CAD design software program. A great place to start is Tinkercad for kids.
Mm-hmm.
And you design something and you print it out, and you're like, oh, I want to do this or want to change that a little bit. So you go in your CAD program, you make that small change, you 3D print it out, and you get the results. If it works, great. If it's finished, great. If not, the great thing about 3D printing is you just go back into the CAD program, tweak stuff, move stuff around, kind of redesign
from scratch.
Right. And then you 3D print it out again. So I love 3D printing because it's really hard to design a robot part perfectly from scratch. So I love to be able to, I'm a visual tactile person, so it really helps me to see things and touch things and be able to measure things and see how things work. And then it's easier for me to visualize, and then I can say, oh, if I just do this, tweak this, move this, and do that in my 3D design program, and then 3D print it out, and then see the results and see how it works and prototype it. And then once I'm totally happy with it, after I've gone through testing and iteration, then I can then do production or inject a molded plastic or whatever with it. But I don't make a major mistake. I don't spend tens of thousands of millions of dollars on something until I'm 100% sure that it's going to work the way I think it's going to work.
So what was the best robot? Like, what was the coolest, your favorite robot that you've ever worked on, like in your whole career?
So,
whoa.
Unfortunately, he's got some issues. All right, demo him for you.
Awesome.
This is a humanoid robot. So this is actually, you can buy this now. It's called the Darwin Mini. But see these gray parts here? Hopefully you can see them. The gray parts are 3D printed. So what the robot basically is, I just kind of help design and develop him and make him kind of look kind of cool. And I 3D printed out the parts for him. Like I said, you can buy him now. I don't know if you know what an Arduino is, but basically
I've heard of those, yes.
He has an Arduino in here, and you can program him using embedded C.
So you guys, do you know what programming is? I know I have a few students here. I actually run a VEX IQ robotics club at my school, and I have at least one or two of the kids are in my robotics club, or were. So they have to program the robots to do different things, and but do you guys understand maybe explain, like, what does it mean to program a robot, and what does that mean when you are a computer programmer or a robotics programmer?
So
looks like he was getting away.
So especially for kids that I'm talking to, the age group I think I'm talking to, I would start out, there's a great programming language for young kids. It's called Scratch. And it's a development of MIT and some other universities. And it's Lego. A lot of kids use a block coding through Lego, has their own environment. So what you're trying to do is, so the microcontroller, the Arduino, the Raspberry Pi, they need to be told what to do. And so how you do that is you have these high-level languages like Python and C and C++ and Scratch, and you basically kind of logically tell something how to program, how to step through something, to develop something, to do something. And the same thing with robots. You program them to step through. Excuse me. You program to step through and do something logically in the steps. And again, it's kind of iteration. You step by step, you break a large concept down to smaller concepts, and you tell the computer, the robot, whatever, the application you're writing, how to do these things in a step-by-step fashion in an order of some type. And it's kind of a logical thinking, but what I tell especially younger kids, that if you don't know what Scratch is, I would definitely go online with your parents' permission. I would go online to the Scratch website and look it over. They got some great videos on how to do for loops and next loops and if statements and if else statements and logical statements. Okay. But they do it in like the Legos, they do it in a block form, a visual form. You just take you take it, put it on the screen, and then you see how it interacts and works in the run environment. It's all web-based, which is pretty cool. And
I'll have to put the link to that on our page, you guys, so you can check that out later for sure. Scratch. That's not one that I have had experience with before. We have little like Azobots at the school that the kids can do different things with, but they may not have had that much experience with it. The basic idea, though, that I think all of these guys have an advantage is all of my students are English learners, which means all of them are so smart they know more than one language. They know English and at least one other language. And when you're programming something, that's kind of like another language. You have to learn how to talk to the robot so it'll understand what you mean and do what you say.
Yes, definitely. So, yes, think of a programming language as another language for you to learn. it's kind of logic based because computers are emotional. They don't respond. They need a logical step-by-step approach to solving a problem or producing an outcome. And some people are really good at it. I know, I will tell you, I'm in the same boat as you. I had to work really hard on my math and my math skills. Math didn't come easy to me, especially the high-level math, the college math. But the more work you put on math now, and the fundamental work that you put on math now will be really helpful for you in the future, because what's going to happen to you is right now you're going, why am I learning this math? Why am I learning trigonometry, algebra, and some of these math? And you'll say, I don't know where this is going to apply. I can guarantee you what's going to happen. You're going to get into college, or you're going to be out working in the job field, and you'll be programming, you're working on robots, and then all of a sudden you'll be going, oh, I remember learning this in high school. I remember this now. Now I know why I spent all that time and effort doing math. It's just going to dawn on you. You're going to go, darn it, why didn't I work harder on math? So I can't tell you that math is not easy. It just takes work and it takes persistence. And if you need help, definitely reach out to people who you think are good in math to help you learn the basic concept of the skills, because I'll guarantee you that if you want to have a cool job, programming robots or programming or 3D printing or anything, it'll get to you. Eventually, you're going to realize that how important math is. I know I got kind of started going off on a tangent there, but but Scratch. I think Scratch is an awesome place to start on programming.
I think Lucas has a question. Lucas, you want to unmute yourself and ask it?
I have got to Scratch, and I know other games like Scratch, like one for practice, or when you go to Scratch, it is one of Google Doodles. And
so you can make Google Doodles? Is that what you're saying?
No, you need to go to Google Doodles.
Oh, is that another program, Lucas? Do you have a question, honey, or are you just making a comment?
A comment?
Okay, well, thank you, hon. Raise your hand, guys, if you have a question, all right?
Yeah, there's different. So MIT has Scratch. Google has their own kind of version of Scratch. So yeah, but they're all very similar. Lego. So yeah, I think I may be missing one, but Google has like a Scratch. MIT has a version of Scratch. And then Lego has, for the Lego, I don't have my Lego robot built, but for the EV3, so the programming environment they have is also very similar to Scratch too. And then you have a little screen, and you basically take the different block code from the sidebar, and move it in, and then you don't actually physically write the code. You have little block statements that you can put in your programming environment and then work it through. It's a really cool way, because it helps you start thinking in the programming way, because it's not like normal speech. It's not like how you normally interact with somebody. It's a more logical step-by-step. And again, I love iteration, but it's an iteration, small step-by-step process. Yeah, but yeah, there's lots of different versions of that block form programming environment out there that you can play around with.
So that robot that's behind you with the eye that keeps blinking at us, what is it? I'm trying to understand what its job is. What is it supposed to do? So
COVID-19 is a great example of what it's caused and happens to do. So there's a lot of people who are self-isolating. Everybody's kind of quarantining themselves. So snow is, think of the easiest way to think of snow as C-3PO, but not in a walking human form. She's a interpersonal robot. She's a robot that can talk to you, interface with you, both through her tablet. Now she doesn't want to talk.
Not in the mood, huh?
Yeah. So if you come into, let's say you come into a business office and you have a receptionist, or you come into a hotel and you have somebody at the front desk, or you come into a restaurant and you have a greeter. So think of Snow in that form. And with the pandemic, I don't want to be scary or anything, but with the pandemic, there's always the risk of when you meeting somebody that you've never met before, you don't know if they're sick or not sick. They don't know if you're sick or not sick. Sometimes nobody knows, unfortunately, that they're sick. And robots can't get sick. Robots can't get COVID-19. So as your first greeter, as the first person you talk to, robots are actually kind of a good in-between. So you can actually mount sensors on this robot, and they can check your temperature, see if you're running the temperature or not. And they can, with their camera, they can see who you are, and they can recognize who you are. So if somebody comes into your office or place of work, it's kind of like a little security guard. She can check your temperature, then she can check who you are. If you're in her database, then she can say, oh, you don't run into temperature, and yes, hi, Mike. Yes, you have an appointment with so-and-so. It's okay. And then, you have now access to the building. Or if you're a receptionist, she can answer basic, simple questions using Amazon AWS and other really cool cloud AI.
So if I walked into my doctor's office and there wasn't a receptionist there, but there was Snow there with a little tablet on her, and she said, hello, can I help you today? And you said, I'm here for the doctor's appointment. Would she be able to say, can you type in the letters of your name and I will look up your appointment? Or what is that, something like that? Or would she just be able to take the temperature?
Even better, if you've already been there, or let's say you've already gone online and entered all your information. So let's say before the appointment, instead of going into the doctor's office, entering all your information there, you had an online form, you entered all your information, and then you had your camera, it's taking my picture, you had your camera take a picture of yourself. So you would have your information plus your picture. So when you walked into the office, her camera would see you, then do facial recognition and say, Melissa. She would say, oh, Melissa, welcome to Dr. Smith. How are you doing? Your appointment is at 11 a.m., which is in 13 minutes. Well, here, it's in 13 minutes. Please have a seat. When the doctor is available, I will call you or tell you it's okay. So think of it. So right now the unemployment rate's kind of high, but before COVID-19 it was really low, especially in the U.S. There was a lot of jobs especially entry-level jobs, that needed to be filled. Very repetitive, simple tasks, just like a receptionist or a greeter, information dispenser, kiosk. A lot of McDonald's are going to kiosks now, and when you can actually go into the sit-down area, instead of talking to somebody, you go right up to a really nice, big, huge screen, touch screen, and you order that way. She could do that same thing, either verbally.
So she can save a person from having to be exposed. You could take the actual receptionist and put her behind something in case somebody really needed it, and then have her go up to the person and take their temperature and do all that stuff. So it could kind of be a safer option. I like that. And for ordering food too, then that saves that person behind the counter. They can go make the food, but yet not have to risk, giving or exchanging sickness. That's kind of a cool thing.
So the other thing that a big thing that a lot of my friends are doing, she's not as capable of this, but she can be modified for this. So think about everybody who's cleaning. Think of bathrooms, public restrooms, public areas where a lot of traffic is happening. So instead of having somebody walk around with a mask on, gloves on, maybe even a suit on to clean the restroom, have the robot go in there with spray disinfectants, UV lights, and then or I've seen a lot of people, they have these spray disinfectants, these foggers. I don't know if you've seen them. So you can put a little backpack fogger on her, and then every once in a while she could drive around the restaurant or the place of business and navigate around autonomously and spray all the common areas, the seats, the doorknobs, your doorknob, your keypads, places where people touch a lot, your seats and stuff. You can go drive around with a backpack sprayer or defogger and fog the place. I've seen really cool applications where the robot who has hands can actually go into a restroom and then have a sprayer, a water sprayer, and spray everything down really good with disinfectant or fogger.
I need one of those in my house. I have 2 sons. That would be great.
Yeah. I think there's a lot of cool, everybody would love to have a robot that can clean their bathrooms every day. I get that all the time.
So many applications for robots. Wow. What I would like you guys to do right now, all the students listening in, either raise your hand or type your questions into the chat box. You can ask questions of Mr. Overstreet either about what his job is or the robots that he's worked with, like the ones you see or other ones I'm sure he's worked with robots you're not seeing right now. Or you can ask about like ideas for your robot design and things that might work or not work. But either type it into the chat box or you can click the raise hand button if you have questions. Because I want to make sure you guys get a chance to ask those questions and get them answered. And then what I've been doing for our guests, Mr. Overstreet, is I've been just making like a shared Google Doc and letting the kids type questions. If you wouldn't mind, I'll share that with you, and then maybe you can answer some of the questions too. Because they always think of them afterwards too. And it's like afterwards you're like, what about this? I'm like, I don't know, but we can ask.
I'm open to questions. Yes.
Awesome. Okay. So Lucas, I still see your hand is up again. Do you have a question this time?
I forget to take the hand.
Oh, you just forgot to take the hand on. That's okay. No problem. Let me look and see here. I want you guys to think about what questions you have, because you had some before. You were asking me all kinds of questions before, and now they're being all shy.
List.
Yeah, now everybody's being all shy. Okay, I have some questions. So can you tell us about any other robots that you've worked with, even if you don't have them, to show us, that do unique or different things, ones that were like challenging to work with or did something unique or different?
So, like I was telling you at the beginning, one of the things I got really heavily involved with is robo games, and one of the competitions I was involved in was Humanoid Robot Kung Fu. So, if you're interested in what Humanoid Robot Kung Fu is, just go out on YouTube and type in Robot Kung Fu, and you'll see it. Basically, it's just boxing, kung fu, kind of MWA, the wrestling, kind of all mixed in together. And
nobody gets hurt that way.
Yeah, so it's really challenging, difficult, and to design the robot, make the robot sturdy enough to survive 3-minute matches. That's a great example of a very challenging application for robotics. Now, unfortunately, you're probably not going to make a lot of money at it, but it's a very challenging application for robotics.
Cool. I do see some hands up now.
Why did you want to make robots?
Ooh.
This is probably going to sound very cliche, and because everybody in robotics is probably going to answer this the same way that I'm going to answer it right now, and you'll see. So when I was a little kid, I can't remember the exact age, but I was really young, I watched Star Wars. And I bet if you talk to almost anybody involved in robotics, one of the first influential, motivating, that's cool, I want to do that responses is probably going to be as they watched Star Wars and they saw R2-D2 and C-3PO and all the droids in the movie, and were like, oh, I want to make one of those. So even though it sounds cliche and pretty for me, I hear this all the time from almost everybody in robotics is, oh, when I was a little kid, I watched Star Wars. But yes, that's the same for me. That's why I was like, oh, I want to do robotics.
I've heard that before, but Star Wars is really good for that. I wonder if we could have so many awesome robots that like vacuum our floors and do all kinds of things if it wasn't for Star Wars, you know?
Well, that's not an interesting topic real fast. I don't want to take all the time. But also back in I can't remember now. I think it's 1984, 1985, the first Terminator movie came out. So one of the interesting discussions I had with friends is in Japan, robots are always the heroes. Robots are always the good guys. Robots are always the protectors in Japan. That's one of their favorite their themes. So people are just really open about robotics and robots in the house and robots in the workforce and robots in public spaces. Now, if you talk to people in the U.S., they have a little bit of a different opinion or thought on robots. They're a little more apprehensive. They're a little bit more, oh, is that a good idea? They're a little more, sometimes a little more scared. And I think it has a lot to do with the Terminator movies. Because even though the Terminator in some of the more recent movies is now the good guy, there's still robot bad guys in the movie. So I think social media, movies and stuff do have influence on that. And I just think it's interesting how, that has influenced us, especially in the U.S. Maybe not for the good, but we're definitely a little more apprehensive compared to some
right.
other countries.
Well, because the idea is that robots, like, they're not people. They're not good or bad. Whoever's telling it what to do might be having good or bad motive, but robots aren't good or bad. They're just doing what they're told because that's all they can do. See, I see some other hands up here. Let me go through my little list here.
What's it like for a robot to be like with you?
So like with Snow can autonomously move around, interact with you. I don't know if she's acting up right now, but it's definitely something to get used to when you first start doing it. But for me, it wasn't that much of, within a few hours, I'm very comfortable around robots, and I'm not apprehensive about robots. For me, it's more like if I see a robot, if I go out and walking around, a great example is when I visited Seoul International Airport a couple years ago. They have robots that drive around and try to help you out and show you where the bathroom is and show you where the ticket counter is and show you where the restroom is. So you can come up and you can interact with the robot through the touch screen or through talking to the robot. And so a lot of people are like, surprised and like, oh, wow, it's unique. But for me, I was really curious to see how the robot worked, see how the robot interacted with people. So luckily I had about a half hour to an hour where I could just hang out around the robot and just watch people and play around with the robot and have the robot take me to restaurants and the restroom and stuff. So for me, I like to just kind of watch the robot and try to think what was the programmer or the engineer thinking when he designed the robot, or what was he thinking when he designed the interface? What was he thinking? Is it a good idea? Is his implementation a good idea, or does he have some flaws? And if he has some good ideas, I put them in the back of my head so that in the future, if I try to design a robot to do something similar, I already have kind of a basis, an idea in the back of my mind of how it would work.
That makes sense. So was that in South Korea in the airport that they had all the robots?
So you're going to start seeing this more and more. I know there's I think it's the Arizona airport has cleaning robots. The Seoul International Airport in South Korea has kiosk information robots. I'm missing a few. I think there's a couple airports in Russia and one in Europe. There's a few, but I think it's, especially think about it in today's age, because everybody, I've seen pictures now of people traveling internationally. They have face masks on, they have gloves on. Some people are even wearing those disposable outfits before they go onto the airport. So what happens is they put those disposable cloth gear on. They get in the airplane. They spend all that time in the airplane, and once they get off, they just dispose of the disposable outfit and the face mask and the gloves. So I'm not saying robots are going to be airplanes, but airports and public areas where there's a lot of traffic, there's a lot of ways. It just helps improve the social distancing. You can talk to a robot, the robot can do cleaning, and so on. You'll see it more and more. Most of right now, it's more of the experiment, the research. A university or a company has put the robots in the airport to do research and development. It's not really widespread, but I think it's going to be in the future. It will be.
I wonder if they'll ever have robots that can like the way that I know that some surgeons sometimes do surgery robotically, like from another state. I don't know, kids, if you guys have heard about this, but a doctor can like put his arms in something and the robot will actually do the surgery on somebody from a couple of states away. That way he doesn't have to get on a plane and fly. But I was wondering if maybe they'd have a robot that looked, kind of like Snow with maybe like a picture of me on it. It could like teach my class for me. And I could do it remotely. I have no idea if that would work, but like that would be kind of a neat thing to have as an option one day. If I got sick and couldn't go to work, I could still, do my job from home. Like, I guess it depends. And then I was wondering, what is the difference between, like, how do they define the difference between a robot and something like an Alexa or a Siri? Because I wouldn't call those a robot, but they can do some of the things that robots can do, So there's like, is it that ability to move that makes it a robot, or what makes a robot a robot?
Okay, so I can't remember the date, but there was a movie in a book. I think it was a European book, Czechoslovakia or something, and the term robot was created. And most of the people, now, I tend to think of a robot as something that moves around, is mobile, but in the purest definition of a robot, you can't say that, well, even my 3D printers, I have people said it's a robot. So your cell phones are close to a robot because you program it and you get them to do something. So the definition is broad for what a robot is and what a robot not. That's another probably discussion we could probably have for an hour, just coming up with examples. So Alexa is, so most people think of like Alexa and Google Home and some of the other online AI programs. They kind of think they're more of as like AI, but chatbots, but they are very close to the definition of what a robot is, because the robot is doing some form or function for you. And if you do look up the definition of robot, it is very broad. A toaster, a household appliance that is programmable and that you can set a timer on, that you can set the temperature and so on beforehand. And like you have a stove. Some of the stoves right now are cooking appliances. Basically, you set the temperature when they start, hours, maybe days in advance. You put all
like my bread machine. My bread machine does that.
So yeah, bread machine is very close to what a robot is, because it is performing a program function for you by itself.
I'm gonna call it a robot from now on. The robot that makes my bread. That's awesome. Lucas, do you have another question?
What's your favorite part of your job?
That is really tough, because there's a lot of cool things that I do, because I design and program. But I do have to say, one of my favorite things to do is, once I got the robot programmed, then it's the testing to see the valuation, to see, I mean, yes, one of the reasons why it's my favorite part is because you put a lot of work into it, And then when the robot performs its form and function the way you want it to, and it does the way, that's a very rewarding experience, or something to experience when something works the way you've spent hours and hours working on, finally works, and you're like, oh yay, I got it to work.
Absolutely. Do you have any hints that would help? You already said a couple of them. So the thing about the extra battery, you guys, they had them at the dollar store, this kind of battery. They're 3-volt. I think they call them cell batteries. I don't know. They're just little circle batteries. They're like $1. They're not expensive. So if you wanted to have the LED lights work without draining the battery, that's another good idea. Any other ideas for how they could like make it not tip over, make it do different things that you feel like would help them in their designs?
So it's kind of like balance. Now, if you have multiple brushes, 2 brushes that you can use, you can do experiments with, like I said, cutting, cutting them to lengths. I've seen people, like if they want the robot to move forward like this, they'll shorten the front bristles, and then to try to speed it up and make it go forward. Now the balancing, I think you said too, you want to get a good balance. So if you could like have the pipe cleaners, even like a penny. So like you put a penny on the front to weigh it down a little bit, maybe a penny on the back or on the sides. Put a little weight, putty or maybe clay. If you don't think the robot is balanced really well on the brush, put a little weight to try to make it more level, more balanced.
Okay. I can allow them to do that. That seems like a reasonable, because I have like my constraints list, but I will add that to the constraints list because that's an easy enough thing to do. What does the robot that you're holding do? It has is that a paintbrush?
Yeah, just a bigger brush. I can't remember now where I got this kit, but it has an on and off button. It doesn't move very well because I haven't really spent a lot of time.
Whoa!
So
if you flipped the paintbrush, would it draw on the paper, I wonder?
Yeah, you could do that, or you could use this as a kind of a guide. You can lengthen it, shorten it. But like I said, I haven't done a lot of experimenting with it. Right now,
that moves all kinds of ways. Wow. I wonder what kind of batteries are in that, because it looks like it's stronger than the batteries we're using.
So it has 2 AAA batteries. But this is a little bit more expensive kit. I don't know how much your kits are.
Oh, I made them myself.
Okay.
So I put together all the pieces. Not terribly expensive because they're so small. But you guys, if you have an extra old toothbrush at home that you're going to throw out, and you want to do like Mr. Overstreet said and like try cutting the bristles on one, you can. I only gave you 1 toothbrush, but you're supposed to change the toothbrush out. Maybe you've got some extra ones hanging out that you're going to throw around anyway. I wouldn't mind that. That's actually some smart thinking. I have not tried cutting the bristles. I just know that when I first tried it and I bought the ones that don't have flat bristles, some toothbrushes have crazy bottom bristles. They all kind of went, whoa, and they wouldn't work. But I bet that's because of the way they were cut. If you cut it in a certain way, it would make it move differently.
Well, I've talked to different people, so I don't know how this works. So make sure you've got multiple brushes, but they cut it at angles. So on the front, they cut them at angles, different angles, and it makes it go straighter or faster. And yeah, I think like that. So
Lucas has got, I think it's a hex bug, which is kind of the same idea as a bristle bot. It's like a vibration motor. It moves in unpredictable ways, like a bug.
Yeah, those hex bugs. So yeah, those hex bugs have different different lengths and orientation of the little feet, and they move differently depending on how they're made. So, but be careful when you start cutting stuff. You don't want to cut too much off or destroy it. Or
can't go back.
Yeah.
That's why I want to have an extra. Another thing I've seen some people try to do, my college students that I did this project with actually. So when I first did this is how much of a novice I am. I attached the little propeller piece and I stuck the whole thing to the poster tape. And I'm like, why is it not working? Because it can't spin. But I had some of the students put it off the end and try to make a little like airplane propeller off the end. And they actually got it to work. It made it a little off balance because it wasn't, perfectly sized, but they put like almost like airplane propellers on it and got the whole thing to spin, and it made it move in a different way. So
Yeah, I love the little experimenting, the little iterations, trying out little different things. And sometimes, like I said, you'll try something and it won't work, but other times it will work not the way you thought it was going to work, but it might actually work better than you thought it was going to work. So I love the little experimenting, the little iterations. I just can't stress to you, don't make big, huge changes. Make small, gradual changes, because sometimes it's really hard to see how something is affecting your robot. If you make a dramatic change, it's hard to figure out exactly what it's doing. If you make small little changes, gradual changes, it's a little easier. At least I find it's a lot easier to figure out why it's doing the way it's doing.
So like if I change the kind of battery and I change what lights I'm putting it on and I cut the bristles and then it doesn't work, how do I know what part of it is it making it work? Or if it does something spectacular, what made it do that? Like, I don't know. But if I change one thing and test it and then change another thing and test it, then that kind of might give me an idea about what does what. And so, okay, that didn't work, so I'm going to try something else. Or this did work really well, so I'm going to keep doing that. So that's something I think you guys should keep in mind. Since we're running out of time, my friends, what I would like you guys to do is if you have any questions about what your design is and what you'd like to do with it for Mr. Overstreet, let's go ahead and ask those questions now, because very shortly here, we're gonna be building, third graders, you guys are gonna go build your robots. These guys are getting used so much tech this summer because we're all virtual. And we're gonna learn more about building the BristleBots and actually get to start doing it today. I figure what better way to have the kids learn about electricity, yes, and robots, we learned about circuits yesterday, than to actually talk to a robotics expert. And I feel like sometimes kids don't even know that some of these jobs exist, and they're the kind of thing that they're going to have a big call for. Lincoln, do you have a question, honey? Go ahead and unmute yourself if you do.
Okay. What was the biggest robot you ever built?
The largest, like size-wise?
That's easy. Snow right here.
That one?
So like 4 feet, maybe? 3 feet?
Yeah, she's a little over a meter tall. She weighs about 70 pounds, I think, 65, 70 pounds. That's the biggest. Now there's a lot bigger robot. A great example, go out on YouTube and type in Gundam Robot Factory, Yokohama, Japan. So for the Olympics, a company in Japan is building a giant-sized Gundam robot that I think is 3 stories tall, and it will be able to move, and it'll be able to move its arms and sort of walk a little bit. But yeah, go out on YouTube with your parents' permission and type in Gundam Robot Factory, Yokohama, Japan. Yeah, like I said, I think it's about 3 stories tall.
That's huge. Oh my goodness. And thank you so much for talking with us today. This was awesome. And I think the kids learned a lot. They were super excited.